use the fundamental trigonometric limit, which is the limit as theta approaches 0. I'm going to write this down. Limit as theta approaches 0 of sine theta over theta. The fundamental trigonometric limit says that this is 1. Right, so we need to use this and the limit laws to determine the following limit, which is the limit as theta approaches 0 of sine 3 theta over theta. Right, so use this to find out this. Okay, right, well, if you look at the fundamental trigonometric limit here, one thing to notice is that you've got here theta approaching 0 and it's sine theta over theta. So the difference here between this and this, here you've got theta approaching 0, here you've got sine 3 theta over theta. So we're not going to be able to apply this limit unless we have the same argument of functions, or the same input basically. So we need this to be the same thing here, here and here. So it's not going to be feasible to turn everything into theta, because to turn sine 3 theta over theta is not going to work. But we can turn this theta into 3 theta quite easily. And the way we do that is multiply top and bottom by 3. It has to be top and bottom because then we're just timesing by 1. If we just times one of them by 3, it would be altering the actual thing that we're trying to find the limit of, which is not allowed and not correct. So this would be equals the lim as theta approaches 0 of 3 sine 3 theta over 3 theta. It's looking a little bit better, but we've kind of got a new problem. But this can easily be removed. So this particular 3, because it's 3 sine 3 theta, you could effectively say what this is really is 3 times all of this. So the sine 3 theta over 3 theta. This is just a constant. It's not affected by how theta is changing, as sine 3 theta over 3 theta is changing as theta approaches 0. This 3, you just multiply it by the end. And the limit law says, or one of the limit laws says, you can just pull constants out. So I will pull this 3 out. So I would say this equals 3 times the limit as theta approaches 0 of sine 3 theta over 3 theta. Right, so now if we compare this limit here to this limit, we're nearly there. We've got the same thing here and here. We've got the 3 theta over 3 theta. The problem is this bit here, theta approaching 0. But if you think about it, as theta approaches 0, or 3 theta also approaches 0, you've got to think we're talking about really, really close to 0. You're talking about sort of zooming in on a graph in 1,000 times. You're talking about getting so close to 0. So from either side it could be 0.000001. It's not sort of infinitely small. It is a finite amount, but it's extremely small. And from the other side, you could be sort of minus 0.00001. Imagine we're really, really, really close to 0. So timesing that number by 3, you're still going to have a really, really tiny number that's really, really close to 0. So we can actually just swap that. So now we have the 3 times the limit as 3 theta approaches 0 of sine 3 theta over 3 theta. So now we can apply the fundamental trigonometric limit and say that all of this here is just 1. So limit as 3 theta approaches 0 of sine 3 theta over 3 theta is 1, and then we just times it by 3. So it equals 3 times 1 equals 3.